In this lesson, we're going to look at congruence in right triangles. The objective is to prove right triangles are congruent using what we are going to learn about is the hypotenuse leg theorem. The first diagram that I have there at the top of the page, if you'll look at that, we have two sides of a triangle that are congruent. BC is 4, QR is 4, AC is 5, and PR is 5. So we have two corresponding congruent sides of two triangles, and we have a congruent angle. Angle A is 45 and angle P is 45. But that angle is not the included angle between those two sides. So it's not angle side angle. We can't use angle side angle. We can't use angle angle side on this one because it's not included. So if you look at this, the triangles have two congruent sides and they have a congruent non-included angle, but they are not congruent. So let's look at why this is this case. This tells us that side-side angle is not a valid method for proving two triangles are congruent, except for the special case when these two triangles are right triangles. So if these two triangles were right triangles and the angles, and we had non-included angles, then we would be able to prove that these two are congruent. So let's scroll down and look at this theorem. So in a right triangle, the side opposite the right angle, just as review, is called the hypotenuse. And it's always going to be the longest side of a right triangle. And the other two sides are called the legs. Now in the hypotenuse theorem, it states that if the hypotenuse and a leg of one right triangle, hypotenuse and a leg of one right triangle are congruent to the hypotenuse and the leg of another right triangle, then those two triangles have to be congruent. So here we have two triangles, two right triangles from the diagrams. So if you look at this, we see that if PR is congruent to XZ, and both of these are the hypotenuse of right triangles, and we can also see from the diagram that PQ is congruent to XY. So we have a pair of legs that are congruent. Then we can state that triangle PQR is congruent to triangle XYZ. Now, just this particular diagram had PQ and XY being congruent. You could have also had the other leg, QR, be congruent to leg YZ in the other triangle. You could have had the other set of legs be congruent, and hypotenuse leg theorem would have still applied here. Let's look at the conditions for the hypotenuse leg theorem. So before you can apply the hypotenuse leg theorem, these conditions have to be true. You have to have two right triangles. The triangles have to have congruent hypotenuse, hypotenuses, and there has to be one pair of congruent legs. So let's look at problem 1 with examples. In problem 1, it says Raymond built 2 triangular supports for a picnic table with the dimensions shown below. Are the supports congruent? So in other words, it's asking, are the triangles congruent? And explain why not. So let's look at these triangles. We have 2 right triangles. The hypotenuse is always the side that's opposite the right angle. So that's how you identify the hypotenuse. So the hypotenuses in these triangles are both a length of 26, so the hypotenuses are congruent. And then we have also a corresponding set of legs that are 24 that are congruent. So we do have the hypotenuses congruent. We have a pair of congruent legs. So we can say yes, they are congruent because of the hypotenuse leg theorem. So let's just again state what's congruent here. The hypotenuses are congruent because 26 is equal to 26. And one pair of legs are congruent. The legs are 24 and 24. Problem 2, we're going to write a proof using the hypotenuse leg theorem. So let's write a 2-column proof with the statements on the left, reasons on the right. Let's look at the given information and mark it on the diagram. It indicates that side AD is congruent to side CD. And it also tells us that angle B and angle D are right angles. So let's write that as our first statement, the given information, that AD is congruent to CB, and that angle B and angle D are right angles. And all of that information was given to us. So let's see what else we can conclude from the diagram. In the diagram, we have a shared side between those 2 triangles. That's side AC. So we know that AC is congruent to AC because of the reflexive property of congruence. And we can also see from the diagram that that is the side that's opposite the right angle in both of those triangles. So that's the hypotenuse for each of those triangles. So we have congruent hypotenuses. We have congruent legs. AD is a leg and BC is a leg of the other triangle. So we can use hypotenuse leg theorem to state that triangle ABC is congruent to triangle CDA by the hypotenuse leg theorem. In problem 3, we have another proof using hypotenuse leg. So let's look at the diagram and see what information is given to us. We're given that side CD is congruent to side EA, and that's already marked in the diagram. And that AD, segment AD, is the perpendicular bisector of segment CE. So if it's perpendicular bisector, we know that we have right angles in these 2 triangles, and we have right triangles. So we need to try to put the statements together to prove that these 2 triangles are congruent. Let's just go again with a 2-column proof. First, it It's the given information. CD is congruent to EA. And AD is a perpendicular bisector of CE. So those are the two pieces of information we're given. So from that information, we can conclude our next statement. Since that is a perpendicular bisector, we can conclude that CB is congruent to EB. That's by the definition of a perpendicular bisector. Perpendicular bisector is perpendicular to the other segment, and it bisects the segment. So CB is congruent, if you want to mark that in your diagram, to BE. And since we do have right triangles, by definition of a right triangle, let's just make a statement out of that. We can state that triangle CBD and triangle EAB are right triangles. And that's by the definition of a right triangle. And then our fourth and last statement, we can state that these two triangles are congruent